This is our war. And this is our plan of attack.
Banks have become an essential threat to our democracy. So consider this justice.
Thank you for listening to Revolution Radio at freedomslips.com, the #1 listener-supported radio station on the internet. Please help support this station so this battle can continue forward. Revolution Radio! The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Good evening, everyone. It's Francis. This is Collision Course, November 10th, 2018, on Revolution Radio at freedomslips.com. Thank you for joining me tonight. It is 6 p.m. in New York City. It is 5 p.m. where I am right now, -6 UTC. I hope wherever you are, if you're listening, you are fine, doing well, and enjoying clear skies. My weather right now is cloudy. A front has moved through after some rain, and it's quite chilly here outside of Houston, Texas. Approximate temperature, I would say, in the lower 60s, going down almost into the 30s at night, unlike our weather. Well, let's get right into the news. First off, let's look at some near-Earth objects, near-Earth asteroids that are fixing to make a close path to Earth. I have been each week looking at this list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 close approach objects that is listed and detailed at the cneos.jpl.nasa.gov/CA/. This list, I guess, is the top 10 near-Earth objects. Last week, we had a couple of flybys by a pair, a couple of flybys by a pair of very similar objects, similar speed, similar timing. We get to this week, and we have a flurry, that's right, a flurry, no pun intended, or maybe a pun intended, of objects going to fly by today and tomorrow. A total of 1, 2, 3, 4, 5, 6, 7, covering November 10th and November 11th, starting with 2018 VD5. And I'm going to go through this. 2018 of November 10th, 422. That was a nominal lunar distance of 4.48. So again, we're working with a number of a lunar distance in the 238,000. That's the number I use, 238,000. So we go 4.5 by 238. You'll get a number. I have a calculator. Let's do that. 238. 1, 2. What? Come on. Click in here. 200, and it's still not going to work for me. That's not very nice. 4.48. 4.48. So we go 4.48 times 238. That comes in at 10. I mean, that's 1,600,066. And now that I found out that's going to be difficult, we're just going to detail rather than trying to figure out how close it is, except for one. There's one that's that's closer than all the rest. But that first one, November 4th at 4:22, that's going to be UT time, 446 minimum lunar distance. The speed is 9.39 kilometers a second. The magnitude was 27, so it was quite dim, very hard to find. Diameter 6.8 meters to 15. 2018 VS1. Now, as I'm looking down here, these are all newly discovered objects. As the months go by of a year, they start at the alphabet of A, and as they discover more objects and they get toward the end of the year, the letters will increase with each month, and now we're on to V. So I am going to make a somewhat educational guess that all these objects, 1, 2, 3, 4, 5, 6, 7, 8 objects were just discovered here in UVW in November. So that's a lot of discoveries. Or V is for October. I don't know. I'll have to look. Maybe we can do it in this show. Why don't we do it right now? It's not like I don't have the time, right? So, asteroid designation V. What month? What month? Asteroid. V type in space. What's our size? What's the number? What are the types? Provisional designation in astronomy. Provisional designation in astronomy is the naming convention applied to astronomical objects immediately following their discovery. The provisional designation is usually superseded by a permanent designation once a reliable orbit has been calculated. In the case of more than 750,000 minor planets, approximately a third remains provisionally designated, as hundreds of thousands have been discovered in the last 2 decades. Minor planets. For the permanent instead of the provisional designation for minor planets, see minor planet designation. The current system of provisional designation of minor planets, i.e. asteroids, centaurs, and trans-Neptunian objects, has been in place since 1925 and superseded several previous conventions, each of which was rendered obsolete by the increasing number of minor planet discoveries. A modern or new style provisional designation consists of the year of the discovery followed by 2 letters and, optionally, a suffixed number. For example, the provisional designation 2016 EK156 stands for the 3910th body identified during 1 through 15 March 2016. 2016, the first element indicates the year of discovery. E, the first letter indicates the half month of the object's discovery within that year and range from A, first half of January, to Y, second half of December. Okay, so Y being the second half of December, UVWXY. So you got XY for December, UVW. So V is the first part of November. We just learned that through our provisional designation in astronomy, looking at these 10 closest. Well, there's one U in there, but they all be V's. 9 out of 10 of these objects, near-Earth objects, coming to make their close approach with Earth were discovered in the first half of November. We're only 10 days into November, so it's been a very busy 10 days. 2018 VD5 flying by November 10th at 4:22 UTC. I'm -6, so I'm going to go right now. I'm at 5:09 p.m., and I'm -6. So right there, they're at 11:09 p.m. So this list really goes down. Most of these have already made their flyby, because right now it's 11:09 p.m. UTC, and 11:09 UTC is 23. So we actually made through them all. But let's conclude this: that 1, 2, 3, 4, 5, 6, 7, 8, 9 out of out of the 10 objects that whizzed by Earth today, one being the closest of 0.99 lunar distances, so that would be something like 237,000 miles from Earth. 2018 VX1 flew by today at 1820 UT. That's 6:20. So at 12:20 p.m. this afternoon in Cypress, Texas, where I am, this 2018 VX1 flew by at 1 lunar distance, or just under 1 lunar distance. So very active list here. This is going to all repopulate because tomorrow, well, the next one is to come by on the 13th at 9.63 lunar distances. 2018 VF5, 8.0 meters, 2018 UQ1, the only one on the list that was discovered last month. So they're all discovered within a month. 2018 UQ1, flyby November 13th, 22:45. 941 lunar distances, speed 938, relative speed 12.34 kilometers a second, magnitude 21.9, 110 meters to 250 meters. That's a good size one there. And then the last on the list is 2018 VO3, 2018 flyby November 14th, 2:15 UTC time. Nominal distance at 4.10, speed at 7.63, magnitude 26.9, 26.9, 11 meters to 25 meters. The list: near-Earth objects, PHAs, potentially hazardous asteroids, as detailed by cneos.jpl.nasa.gov. Gives you the list, tells you, details what's coming up. In this case, it only covers so many days because there's so many objects, and they give you the top 10. We learn provisional designation, so when we see a year and then a letter, we can come back to provisional designation and know that each letter, A through Y, which equals the second half of December, everything in between is a half a month. So A is a half of December, half of January, B is a half of January, C is a half of February, D is a half of February, and so on and so forth. You can discover with that information the year, because it tells you, and then the month that it was discovered. Close the calculator. That didn't work. Close the top 10 list. And moving on. Most of this show, as I guess a lot of the others already, is going to focus on our interstellar traveler, Oumuamua. So much news and information. All the outlets have a say. Everybody's got information. Is it a space alien? Is it an alien craft? Like I say, is it a scout? Really? Out to check out the enemy? I don't know. It's just fun to mess with. That's messing with your words. But out of all honesty, I didn't make up the words. But I have here in front of me a number of informative reports, articles, information that all relate and refer back to Oumuamua. Let's go right here to physics.org, because the real question these days is, could Oumuamua be an extraterrestrial solar sail? We're going to make a distinction this evening in the time that we have. Hopefully it'll be enough, because there's a lot of information. We have to understand when we're listening to our favorite news outlet, our favorite news person, that the news that they're giving you may be construed in such a way as to make the news more important than the facts that are behind the news. It's easy to listen to the news, and we're getting more and more this way, unfortunately, and I'm sticking to my topic of choice, being outer space, but we have to make this recognition, even in this topic, that sometimes when we're dealing with new discoveries, not undiscovered, but misunderstood, understood, do not have the full meaning or explanation of what's going on, that when a story or a report comes out about something like that, it is based on normally only snippets of information. They are the clickbait of article segments. It's the only way I can think of it is that clickbait is the perfect way, the way to get most views out of a particular topic is to create a headline or a caption which most instigates action by the reader or viewer. So much so that, the intention even goes so far, advertisers will go so far as to intentionally include manipulating advertisements to entice one to move in a certain way, one way or the other. But in this instance, what I'm getting down to is we have a lot of articles about Oumuamua, all the news outlets, the physics.org, the astronomy, the space.com, the people like Phil Plait and Bad Astronomy. I'm sure that Neil deGrasse Tyson has had his say. And for all this information that comes out, they are somehow shading or shedding the information to which they created the news story on. Because the information they're creating the news story on is scientific in nature, research-driven, and the work product of scientifically research-driven product are research papers which detail data, information, and hypotheses derived from the detailed data and information. These papers are then submitted, I'm sure, like to higher-ups in the scientific community. We have had important departments, or should I say, we have had scientific departments from important institutions saying, or how do I say, adding their 2 cents, which adds even more interest overall for someone like myself and hopefully someone like you, the listener. I don't want to say much of it is what is a purpose, because the purpose can only be imagined, and imagination should be left to the individual, while the facts should be dispersed amongst the group. And that's what we're going to do a little bit tonight. But let's look at what has been coming up lately when we hear about our interstellar traveler, Oumuamua. Could Oumuamua be an extraterrestrial solar sail? And we'll just go with it, and we'll see how much description it includes. Most of my articles, I'll read it through with the listener. So you're going to hear it as I read it. On October 19, 2017, the Panoramic Survey Telescope and Rapid Response System-1, in parentheses, PanSTARRS-1, in Hawaii announced the first ever detection of an interstellar asteroid named 1I/2017 space U1, in parentheses, aka Oumuamua, spelled Oumuamua. In the months that followed, multiple follow-up observations were conducted that allowed astronomers to get a better idea of its size and shape, while also revealing that it had the characteristics of both a comet and an asteroid. Interestingly enough, there has also been some speculation that based on its shape, Oumuamua might actually be an interstellar spacecraft. Parentheses, breakthrough, listen, even monitored it for signs of radio signals. A new study by a pair of astronomers from the Harvard-Smithsonian Center for Astrophysics, that's the CFA, has taken it a step further, suggesting that Oumuamua may actually be a light sail of extraterrestrial origin. The study, in quotes, could solar radiation pressure explain Oumuamua's peculiar acceleration, unquote, which recently appeared online, was conducted by Shmuel Bialy and Professor Abraham Loeb, whereas Bialy is a postdoctoral researcher at the CFA's Institute for Theory and Computation, ITC. Professor Loeb is the director of the ITC, the Frank B. Baird Jr. Professor of Science at Harvard University and the head chair of the Breakthrough Starshot Advisory Committee. Now I'll stop there. We actually have contact with Professor Loeb, and he was on his way to Germany and expected back next week. I hope to initiate another email upon his return and secure an interview with him on an upcoming episode. He seems to be open to the idea, and I sure do hope that he follows through. And I'll continue here, because he'd be a great person to hear from concerning Oumuamua. And we'll go right back to it. Professor Abraham Loeb is a director of the ITC, the Frank B. Baird Jr. Professor of Science at Harvard University, and the head chair of the Breakthrough Starshot Advisory Committee. Interesting. To recap, Oumuamua was first spotted by the PanSTARRS-1 survey 40 days after it made its closest pass to the Sun on September 9th, 2017. At this point, it was about 0.25 AU from the Sun, 1/4 the distance between the Earth and the Sun, and already on its way out of the solar system. In that time, astronomers noted that it appeared to have a high density, indicative of a rocky and metallic composition, and that it was spinning rapidly. While it did not show any signs of outgassing as it passed close to our Sun, which would have indicated that it was a comet, a research team was able to obtain spectra that indicated that Oumuamua was more icy than previously thought. Then, as it began to leave the solar system, the Hubble Space Telescope snapped some final images of Oumuamua that revealed some unexpected behavior. After examining the images, another international research team discovered that Oumuamua had increased in velocity rather than slowed down as expected. The most likely explanation, they claimed, was that Oumuamua was venting material from its surface due to solar heating, aka outgassing like a comet. The release of this material, which is consistent with how a comet behaves, would give Oumuamua the steady push it needed to achieve this boost in velocity. To this, Bialy and Loeb offer counter-explanation. If Oumuamua were in fact a comet, why then did it not experience outgassing when it was closest to the sun? In addition, they cite other research that showed that if outgassing were responsible for the acceleration, it would have also caused a rapid evolution in Oumuamua's spin, which was not observed. Basically, Bialy and Loeb consider the possibility that Oumuamua could in fact be a light sail, a form of spacecraft that relies on radiation pressure to generate propulsion, similar to what Breakthrough Starshot is working on. Similar to what is planned for Starshot, this light sail may be sent from another civilization to study our solar system and look for signs of life, as Professor Loeb explained to Universe Today via email. Quote, "We explained the excess acceleration of Oumuamua away from the sun as the result of the force that the sunlight exerts on its surface. For this force to explain measured excess acceleration, the object needs to be extremely thin, of order a fraction of a millimeter in thickness, but tens of meters in size. This makes the object lightweight for its surface area and allows it to act as a light sail. Its origin could be either natural, in the interstellar medium or protoplanetary disks, or artificial, as a probe sent for a reconnaissance mission into the inner region of the solar system." What? Isn't that what the name means anyways? The probe sent for the reconnaissance mission into the inner solar region of the solar system to find the enemy. Where the enemy? So that's what they say. I didn't make it up. God. Based on this, Bialy and Loeb went about calculating the likely shape, thickness, and mass to area ratio that such an artificial object would have. They also attempted to determine whether this object would be able to survive in interstellar space and whether or not it would be able to withstand the tensile stresses caused by rotation and travel forces. We're going to be coming up on break here in a minute. As soon as I hear the ding-ding, I'm going to stop. So they're looking at it and they're trying to figure out if it has the tensile strength to do all this maneuvering it's doing, if that's what it is. What they found was that a sail that was only a fraction of a millimeter thick, 0.3 to 0.9 millimeter, would be sufficient for a sheet of solid material to... And I'll get back right after the break.
freedomslips.com, and we'll be right back after this message.
Narco-syndicalist commune. We take it in turns to act as a sort of executive officer for the week. Yes. But all the decisions of that officer have to be ratified at a special bi-weekly meeting. Yes, I see. By a civil majority in the case of purely internal affairs. Be quiet. But by a 2/3 majority in the case of more... Be quiet. I order you to be quiet. Look, you stupid bastard, you've got no arms left. Yes, I have. Look! It's just a flesh wound.
I don't believe I've seen such a display of courage, skill, nerve, grace, stupidity.
I'll do you for that. Oh, what? Come here. What are you going to do? Bleed on me? I'm invincible. You're a loony.
The Black Knight always triumphs!
Roundtable Live, Monday through Friday, 1 a.m. till 4 a.m. Eastern Time. Bring your mind, bring your ideas, bring your voice. King Arthur had nothing on us here at Revolution Radio, freedomslips.com.
Enjoy your
extra big-ass fries.
You didn't give me no fries. I got an empty box.
Would you like another?
Extra big-ass fries.
I said I didn't get any.
Thank you. Your account has been charged. Your balance is 0. Please come back when you can afford to make a purchase.
No.
I'm sorry you're having
trouble.
trouble.
Come on. My kids are starving.
Thank you for tuning in to Revolution Radio. Here at Revolution Radio, we believe in freedom of ideas, freedom of speech, but above all, we believe in freedom of existence through self-reliance. This station is 100% listener-supported, and as a fundraising promotion, I have a kick-ass free gift for a $100 donation. 35,000 seeds. 25 years in the freezer. Long-term storable, 54 different varieties. So if food prices go crazy, the shit hits the fan, or if you just want to save tons of money every year by creating your own food like I do, grab our seed pack special. Just look for the banner on the homepage at freedomslips.com. Don't be a statistic. Don't be part of the problem. Be part of the solution. We need, as humans, to start taking care of ourselves and not depending on the megacorps to provide unhealthy, nasty food. Included in this package is also a DVD with 900 survival and off-grid living documents and the offline home canning how to do everything website all on the DVD. So when you're growing all that food, you know how to can it, store it, preserve it, etc. with all these documents. So thank you for tuning in to Revolution Radio at freedomslips.com. I hope that you will pick up this package and start learning to be free. Revolution Radio, freedomslips.com, where information never sleeps and freedom is one seed that needs to be planted.
What we do in life, that goes in eternity.
Thanks for tuning in to Revolution Radio. Here at Revolution Radio, we are listener-sponsored and commercial-free. But there still are bills to pay. In order to raise some needed funds to cover the cost, our station is offering a silver special. In the continental United States for a $60 donation, or in Alaska, Hawaii, or Canada for a $70 donation, we will send you an uncirculated 2018 1-ounce pure silver Eagle. The $70 donation, the extra 10 is to cover shipping, by the way, outside of the continental United States. When making the donation, you must put Silver Eagle promo in the notes on the donation. And thank you for tuning in to Revolution Radio at revolution.radio and freedomslips.com. Without you, there is no us. Revolution Radio, where information never sleeps.
The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Hello, everybody. 5:34 here in Cypress, Texas. 11/10/2018. That's November 10th, 2018. We're here on Collision Course on Revolution Radio at freedomslips.com talking about our interstellar traveler, Oumuamua. Is it something that we really should watch out for? How much do we need to know? Well, considering how much information has come out, it appears we need to know a lot if we're really interested in things like this. And I've told myself and pride myself in wanting to know about these things, so I'm sharing it with you. We are reading out of the article titled, Could Oumuamua Be an Extraterrestrial Solar Sail? Physics.org. We are halfway through down where we were talking about what the physical parameters of this solar sail might have to be in order for it to attain the changes in velocity that has been recorded as the object was moving away from Earth. What scientists found was that a sail that was only a fraction of a millimeter thick, 0.3 to 0.9, would be sufficient for a sheet of solid material to survive the journey through the entire galaxy. Though this depends greatly on Oumuamua's mass density, which is not well constrained, thick or thin, this sail would be able to withstand collisions with dust grains and gas that permeate the interstellar medium, as well as centrifugal and tidal forces. This is an area where I have to say that it's kind of hard to understand our picture of the object. Our picture of the object to date, after a number of shows in my mind, is a elongated object that is a lot like a plate. But up until I think I'm going to get past this episode, we're going to have to throw in the possibility that, okay, this is an oblong object like a plate, but we're going to have to then, on the magnitude of 100, thin this plate down to something that's just a few millimeters thick. And we don't know the full surface area, but the scientists in this paper that we'll be coming up on is trying to detail how they're going to get the velocity changes required from the observations of the object itself. So we have facts, which are observations, the observation that the object was speeding up on its way out. And now, two, we're going to have hyperbole and a hypothesis to recognize and understand what the cause was. As for what an extraterrestrial light sail would be doing in our solar system, Bailey and Loeb offer some possible explanations for that. First, they suggest that the probe might actually be a defunct sail floating under the influence of gravity and stellar radiation, similar to debris from shipwrecks floating in the ocean. This would help explain why Breakthrough's Listen found no evidence of radio transmissions. If you were a scout, wouldn't you have radio silence? Radio silence, people. Expect it. Loeb further illustrated this idea in a recent article he penned for Scientific American. I really hope I get to interview Mr. Loeb, where he suggested that Oumuamua could be the first known case of an artificial relic which floated into our solar system from interstellar space. What's more, he notes that light sails with similar dimensions have been designed and constructed by humans, including the Japanese design Ikaros project and the Starshot initiative with which he is involved. This opportunity establishes a potential foundation for a new frontier of space archaeology, namely the study of relics from past civilizations in space, Loeb wrote. Finding evidence for space junk of artificial origin would provide an affirmative answer to the age-old question, are we alone? This would have a dramatic impact on our culture and add a new cosmic perspective to the significance of human activity. On the other hand, as Loeb told Universe Today, Oumuamua could be an active piece of alien technology that came to explore our solar system the same way we hope to explore Alpha Centauri using Starshot and similar technologies. The alternative is to imagine that Oumuamua was on a reconnaissance mission. The reason I contemplate the reconnaissance possibility is that the assumption that Oumuamua followed a random orbit requires the production of 10 to the higher power of 15 such objects per star in our galaxy. This abundance is up to 100 million times more than expected from the solar system based on a calculation that they did back in 2009. A surprisingly high overabundance unless Oumuamua as a targeted probe on a reconnaissance mission and not a member of a random population of objects. According to Loeb, that there's also the fact that Oumuamua's orbit brought it to within 0.25 AU of the Sun, which is a good orbit for intercepting Earth without experiencing too much solar irradiation. In addition, it came to within 0.15 AU of Earth, which could have been the result of orbital corrections designed to facilitate a flyby. Alternatively, he states that it is possible that hundreds of such probes could be sent so that one of them got close enough to Earth to study it. The fact that the Pan-STARRS 1 survey barely detected Oumuamua at its closest approach could be seen as an indication that there are many other such objects that were not detected, bolstering the case for Oumuamua being one of many such probes. Considering that astronomers recently concluded that our solar system has likely captured thousands of interstellar objects like Oumuamua, this opens the possibility for future detections which could help prove or disprove the case for an interstellar light sail. Naturally, Violet and Loeb acknowledge that there are still too many unknowns to say with any certainty what Oumuamua really is, and if it does happen to be a piece of natural rock. All other asteroids and comets that have previously been detected have had mass-to-area ratios orders of magnitude larger than the current estimates of Oumuamua. Let me read that again. Naturally, Bailey and Loeb acknowledge that are still too many unknowns. I'm going to fix that. Naturally, Bailey and Loeb acknowledge that there are still too many unknowns to say with any certainty what Oumuamua really is. And even if it does happen to be a piece of natural rock, all other asteroids and comets that have previously been detected have had mass-to-area ratios orders of magnitude larger than the current estimates for Oumuamua. So that says there that this is a one-time shape. One time. They said that all other asteroids and comets that have previously been detected, all other have been magnitudes, mass-to-area ratios, orders of magnitude larger than the current. That, and the fact that radiation pressure appears to be capable of accelerating it, would mean that Oumuamua represents a new class of thin interstellar material that has never before been seen. If true, that opens up a whole new set of mysteries, such as how such material was produced and by what or whom. While it has been beyond the reach of our telescopes for almost a year now, Oumuamua is sure to remain the subject of an intense study for many years to come, and you can bet astronomers will be on the lookout for more of them. After all, the Ramans do everything in three, right? That's R-A-M-A-N-S, do everything in three, right? Right. Whatever you say. That whole article was just filled with it was an interesting article because they are just saying things. They're just saying it without any, normally in the past, these articles that would present these type of theorems would be met with the hardline scientists who say we must we must start here before we go here. We must start here before we get here. Now we're just getting such oddball results out of the observations that they're going right into explanations that take this object into places we've never been before. Okay, here's the paper behind the article. So we know what the article stated. Had a lot of quotes from Avi Loeb, Abraham Loeb, Shmuel Bialy, and I may not be saying his name right. Forgive me if I am. That's Shmuel, Shmuel, Bialy, Bialy, Shmuel Bialy, and Abraham Loeb. He said when Abraham Loeb wrote back to me, it was Avi, A-V-I Loeb. Harvard's Smithsonian Center for Astrophysics at 60 Garden Street, Chambers, Mass. 02138. Accepted for publication in the Astrophysical Journal Letters. So this is where the science goes. When we're talking about, I don't know how to say it. When we talk about science that sketch, they're not going to have these papers written on them. Now, when you're talking about a science that sketch, and now that sketch science has plenty of believers, and the believers have created documents after documents, a million ways to prove this, 10,000 ways to prove this and that. What you're going to lack and what you're going to find lacking are these types of papers, accepted for publication in the Astrophysical Journal Letters. So when you want to come to the table to talk about theorem, hypothesis, facts, and otherwise observations, let's talk about real papers versus fiat papers. We'll call them fiats. All that fiat paper that's out there talking about fiat science. The abstract for this is Oumuamua. That's 1I/2017 U1 is the first object of interstellar origin observed in the solar system. Recently, this McKelly et al. 2018 reported that Oumuamua showed deviations from a Keplerian orbit at a high statistical significance. The observed trajectory is best explained by an excess radial acceleration Okay. Now, in this article, there are mathematical computations. I cannot translate to you what they represent, so we're going to have some gaps, and we're going to have to move through it because there's still enough information outside of those mathematical gaps for us to ascertain some good information. So let's go. The observed trajectory is best explained by an excess radial acceleration computation, where part of the computation is the distance of Oumuamua from the Sun. Such an acceleration is naturally expected for comets driven by evaporating material. However, recent observational and theoretical studies imply that Oumuamua is not an active comet. They do not see any outgassing. They didn't see any increase in outgassing when it was closest to the Sun. The group explores the possibility that the excess acceleration results from solar radiation pressure. The required mass to area ratio is computation MA equals 0.1 GCM minus 2 power. For a thin sheet, this requires a thickness of 0.3 to 0.9 millimeter. They find that although extremely thin, such an object would survive an interstellar travel over galactic distances of 5 kpc, withstanding collisions with gas and dust grains, as well as stresses from rotation and tidal forces. They discuss the possible origins of such an object, including the possibility that it might be a light sail of artificial origin. Their general results apply to any light probe designed for interstellar travel. Subject headings: ISM, individual object 1I/2017 space U1 dash minor planets, asteroids, individual parentheses 1I/2017 space U1 for parentheses dash general extraterrestrial intelligence dash minor planets, asteroids, general. These are the keywords. General keyword extraterrestrial intelligence. Introduction. On October 19th, 2017, the first interstellar object in the solar system, Oumuamua 1I/2017 space U1, was discovered by Pan-STARRS survey. It has a highly hyperbolic trajectory with an eccentricity E equals 1.1956.0006 and pre-entry velocity of V equals 26 kilometers a second to the -1 power, Meach et al. 2017, based on the survey properties and the single detection, Doe et al. 2018, estimated the interstellar density of objects like Oumuamua or larger to be n equals 2 times 10 to the 15th power, PC -3 power, 2 to 8 orders of magnitude larger than expected by previous theoretical models. Morrow-Martin et al. 2009. The large variations in its apparent magnitude and the non-trivial periodicity of the light curve suggests that Oumuamua is rotating in an excited spin state, tumbling motion, and has an extreme aspect ratio of at least 5:1. Fraser et al. 2018, Drawhouse et al. 2018. An unprecedented value for previously known asteroids and comets in the solar system, Belton et al. 2018, have shown that if Oumuamua rotates in its highest rotational energy state, it should be extremely oblate, parentheses, pancake-like. Recently, Michelli et al. 2018 reported the detection of non-gravitational acceleration in the motion of Oumuamua at a statistical significance of 30 function. Their best fit to the data is obtained for a model with a non-constant excess acceleration, which scales with distance from the Sun r as function r to the -2 power, but other power law index values are also possible. They concluded that the observed acceleration is most likely the result of a cometary activity. Yet, despite its close solar approach of r equals 0.25 AU, Oumuamua shows no sign of any cometary activity. No cometary tail nor gas emission absorption lines were observed. Meach et al. 2017, Knight et al. 2017, Jewett et al. 2017, Ye et al. 2017, Fitzsimmons et al. 2017. From a theoretical point of view, Rafikov 2018 has shown that if outgassing was responsible for the acceleration as originally proposed by Michelli et al. 2018, then the associated outgassing torques would have driven a rapid evolution in Oumuamua's spin, incompatible with observations. If not cometary activity, what can drive the non-gravitational acceleration observed? In this letter, we explore the possibility of Oumuamua being a thin object accelerated by solar radiation pressure, which would naturally result in an excess acceleration, function r to the negative 2 power. However, for radiation pressure to be effective, the mass-to-area ratio must be very small. We derive the required mass-to-area ratio and find M4/A equals 0.1 G cm negative 2 power, corresponding to an effective thin sheet of thickness 0.3 to 0.9 millimeters. We explore the ability of such an unusually thin object to survive interstellar travel, considering collisions with interstellar dust and gas, as well as to withstand the tensile stresses caused by rotation and tidal forces. Finally, we discuss the possible implications of the unusual requirements on the shape of Oumuamua. This part's going to get really function heavy. I'm going to be skipping functions reading so we can try to get some information out of it. It's called acceleration by radiation pressure. So this is going to be the part where they detail, and we're going to be on break. And when we come back, we'll start right up with the acceleration by radiation pressure on Oumuamua. Is it a scout that we let go? We don't know.
Radio at freedomslips.com, and we'll be right back after this message.
Narco-syndicalist commune. We take it in turns to act as a sort of executive officer for the week. Yeah. But all the decisions of that officer have to be ratified at a special bi-weekly meeting. Yes, I see. By a simple majority in the case of purely internal affairs. Be quiet. But by a 2/3 majority in the case of more... Be quiet. I order you to be quiet. Look, you stupid bastard, you've got no arms left. Yes, I have. Look! It's just a flesh wound.
I don't believe I've seen such a display of courage, skill, nerve, grace, and stupidity.
I'll do you for that. What? Come here. What are you going to do, bleed on me? I'm invincible. You're a loony. The Black Knight always triumphs.
Roundtable Live, Monday through Friday, 1 a.m. till 4 a.m. Eastern Time. Bring your mind, bring your ideas, bring your voice. King Arthur had nothing on us here at Revolution Radio, freedomslips.com.
Enjoy your
extra big-ass fries.
You didn't give me no fries. I got an empty box.
Would you like another?
Extra big-ass fries.
I said I didn't get any.
Thank you. Your account has been charged. Your balance is 0. Please come back when you can afford to make a purchase.
No.
I'm sorry you're having
trouble.
trouble.
Come on. My kids are starving.
Thank you for tuning in to Revolution Radio. Here at Revolution Radio, we believe in freedom of ideas, freedom of speech, but above all, we believe in freedom of existence through self-reliance. This station is 100% listener-supported, and as a fundraising promotion, I have a kick-ass free gift for a $100 donation. 35,000 seeds. 25 years in the freezer. Long-term storable, 54 different varieties. So if food prices go crazy, the shit hits the fan, or if you just want to save tons of money every year by creating your own food like I do, grab our seed pack special. Just look for the banner on the homepage at freedomslips.com. Don't be a statistic. Don't be part of the problem. Be part of the solution. We need, as humans, to start taking taking care of ourselves and not depending on the megacorps to provide unhealthy, nasty food. Included in this package is also a DVD with 900 survival and off-grid living documents and the offline home canning how to do everything website all on the DVD. So when you're growing all that food, you know how to can it, store it, preserve it, etc. with all these documents. So thank you for tuning in to Revolution Radio at freedomslips.com. I hope that you will pick up this package and start learning to be free. Revolution Radio, freedomslips.com, where information never sleeps and freedom is one seed that needs to be planted.
What we do in life, it goes in eternity.
Thanks for tuning in to Revolution Radio. Here at Revolution Radio, we are listener-sponsored and commercial-free. But there still are bills to pay. In order to raise some needed funds to cover the cost, our station is offering a silver special. In the continental United States for a $60 donation, or in Alaska, Hawaii, or Canada for a $70 donation, we will send you an uncirculated 2018 1-ounce pure silver Eagle. The $70 donation, the extra 10 is to cover shipping, by the way, outside of the continental United States. When making the donation, you must put Silver Eagle promo in the notes on the donation. And thank you for tuning in to Revolution Radio at revolution.radio and freedomslips.com. Without you, there is no us. Revolution Radio, where information never sleeps.
The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Welcome back, everyone. Part 2 of Collision Course on Revolution Radio at freedomslips.com from 6 to 8 p.m. in New York City every Saturday night. You can come here listening to your friend Francis Walsh talking about the things in space that interest him the most, or what's on the top of the list of things to talk about for things out in space. For the past so many weeks or months, we've been getting these new reports and papers regarding our interstellar traveler. The interstellar traveler Oumuamua, discovered back in 2017, October 19th, though I have it under good report that it was actually October 16th, so I don't know why they're saying October 19th, but that's just another twist to the plot of Oumuamua. The twist keep turning as this object keeps on getting more interesting. We are now inside the paper behind the headlines, the paper which details how the scientists from the Harvard-Smithsonian Institute came up with their hypothesis theory that this object could be an alien light sail. Their theory was derived from the observations of velocities, exit velocities, which continued to increase for the object once it had passed the sun. The speed of objects coming around an orbit close to the sun feel their greatest tug of the sun's gravity on the way in, and it gets sucked around and spit out the other side, and on the other side it would slowly slow down because of the pull or tug of the gravitational weight of a large object is diminishing. Well, through observations, a radial increase of velocity was measured, and the scientists went to work. All the scientists from the latest and greatest research institutions like Harvard and Caltech and Hawaii are all in on this object. They all have their interesting points of view. But behind the points of view, behind the articles, the clickbait articles, look at me articles, are the papers that are submitted to the journals that get peer reviewed. Again, we spoke before the break about Sketch Science and how Sketch Science has a hard time standing up because they failed to have the adequate papers presented and accepted in scientific journals. Well, some might say, well, the reason why they don't have their papers accepted is because the scientific journals won't accept them. I would hope that the scientific journals wouldn't accept some Sketch Science. But that's just being the devil's advocate of that kind of thing. And we're not talking about any particular Sketch Science. We're just talking about Sketch Science in general. But then again, if you look at this, is this Sketch Science? Well, it may be, but they're submitting it to the journals for peer review. And if the peer review can't come up with an alternate reason for these accelerations, then they have to look at these theories and hypotheses seriously. Let's see if I can make it through the acceleration by radiation pressure, because there's just a lot of functions and math involved, and it's going to sound really broken up. But we have to go through it, see if there's something we can ascertain from it. McKelly et al. 2018 had shown that Oumuamua experiences an excess radial acceleration with their best fit model functions. The value for A is averaged over time scales much longer than Oumuamua's rotational period. An acceleration of this form is naturally produced by radiation pressure function. P pressure equals a function CR L over 4 pi r to the second power C, where L is the solar luminosity, C is the speed of light, and CR is a coefficient of order unity which depends on the object's composition and geometry. For a sheet perpendicular to the sun object vector, CR equals 1 plus E, where E is the reflectivity. So, it's an important function there. It all lies right in there. So what they're able to do with that function, P equals CR times L over 4 pi r to the second power C, is determined where L is the solar luminosity, C is the speed of light, and CR is a coefficient of the order unity, which depends on the object's composition and geometry. For a sheet perpendicular to the sun's object vector, CR equals 1 plus E, where E is the reflectivity. So it's given us the parameters of what they need to get acceleration from solar radiation. And that's really what we're talking about. How does the solar sail work? It works off solar radiation. What's solar radiation? Solar radiation is space weather. It's the same kind of weather that our magnetosphere protects Earth from, those protons and energized particles constantly coming off the surface of the sun. Those types of particles are propelling technologies that enlist thin sheets to be pummeled by the particles and propel it forward. It is a sail. Imagine it to be a large squarish sail that uses the solar space weather as its propellant and torque to push forward. Momentum transfer slowdown. An object with a cross-sectional area, A, traveling a distance L through the interstellar space medium, would accumulate an interstellar space medium gas mass of M gas equals E gas equals 1.4 MPNLA, where E gas is the accumulated mass column density of interstellar gas. MP is the proton mass. N is the mean proton number density averaged along the object's trajectory, and the factor 1.4 accounts for the contribution of helium to the mass density of the ISM, inner space medium. For trajectories that span galactic distances, the contribution of the solar system to the accumulated column is negligible. The contribution of accumulated dust to the momentum transfer is also negligible, because the typical dust-to-gas mass ratio in the galaxy equals 1 to the 100th. Once ISM approaches the object's mass, m, the momentum of the traveling object will decrease by a significant amount. The requirement ISM divided by m less than 1 translates into a maximum allowed value on the object's mass-to-area ratio, giving function. In the last equality, we normalize to the typical values. Function given to mass-to-area ratio, the maximum travel distance is function. In the second equation, we denoted MA1, MA10 to the 1 GCM2. Figure 1 shows the result from E equals 9. As a function of MA, the dashed vertical line indicates our constraint on MA for Oumuamua. Evidently, Oumuamua can travel galactic distances before encountering appreciable slowdown. Energy transfer. Collisions with dust grains. Collisions with dust grains at high velocities will induce crater formation by melting and evaporation of the target material. Since the typical time between dust collisions is long compared to the solidification time, any molten material will solidify before the next collision occurs, and thus will only cause a deformation of the object's surface material, not reduction in mass. On the other hand, atoms vaporized through collisions can escape and thus cause a mass ablation. We would like to estimate the minimum mass-to-area ratio required for the object to not lose significant fractions of its mass upon dust grain collisions. Let MD be the colliding dust grain mass and O the fraction of the kinetic energy that is converted into vaporization of the object's body. The total number of vaporized atoms per collision is then function, where MV is the mass of vaporized material in the object, M is the mean atomic mass of the object, and U is the vaporization energy. Although highly simplistic, this analysis captures the result of the detailed theoretical model of Thielens et al. 1994 and the empirical data from O'Keefe and Averins 1977. A good match to the numerical results is obtained for O equals 0.2. Over a distance L, there will be many collisions. Adopting the conservative assumption that for each collision, all the vaporized material escapes to the ISM, we can account for all the collisions along a path length L by replacing MD in EQ with the total accumulated dust mass, where E dust is the dust column density and ODG is the dust to gas mass ratio. This gives a function requiring that the total vaporized mass not exceeding half of the object's mass. We obtain a constraint on the minimum mass-to-area ratio of the object. Here we define the normalized parameters as appropriate for carbon-based materials, graphite, or diamonds, as appropriate for typical vaporization energies for graphite, and the velocity at infinity of Oumuamua for a given mass-to-area ratio. The maximum allowed distance before significant evaporation is. For our constrained value for the mass-to-area ratio, Oumuamua can travel through the entire galaxy before a significant fraction of its mass is evaporated. Evaporation becomes important at higher speeds. Comparing EQs 8 and 13, we find that only for speed above, vaporization dominates over slowdown. Energy transfer, collisions with gas particles. When an object travels at a high speed, collisions with atoms in the interstellar space medium can potentially transfer sufficient energy to produce sputtering. This process was studied in the context of dust grains and hot shocks. Thielens et al. 1994. For an object traveling at a velocity v over a distance L through the ISM, the total number of sputtering particles is ns equals ms over m equals 2al ny tot, comma, where y tot and yixi is the total sputtering yield, which depends on the kinetic energy, summed over collisions with different species, i.e. H, He, and metals, and X is the abundance of the colliding species relative to hydrogen. The minimal mass-to-area ratio below which half of the object's mass will be sputtered is, in the second equality we normalize corresponding to kinetic energies, corresponding to V equals 40 minus 70 kms per second for lower speeds as that of Oumuamua, the yield is even lower, further decreasing the value of MAMS. At higher speeds, the yield increases but typically remains below 0.01, Thielens et al. 1994. Thus, at any velocity, vaporization and slowdown remain the dominating processes, limiting the allowed distance an object can travel through the interstellar space medium. Cosmic rays are expected to cause even less damage, although their energy density is comparable to that of the interstellar space medium gas. They deposit only a very small fraction of their energy as they penetrate through the thin object. A thin object can be torn apart by centrifugal forces or tidal forces if its tensile strength is not sufficiently strong. Typical values for the tensile strengths of various materials are shown in Table 1. Next, we calculate whether centrifugal or tidal forces can destroy Oumuamua. Rotation. Oumuamua's light curve shows periodic modulations on an order of 6 to 8 hours. Ignoring the tumbling motion, let us estimate the tensile stress originating from the centrifugal force. The largest stress is produced if the object is elongated, such that the longest dimension is perpendicular to the rotation axis. We denote this dimension as d, considering the object as made of two halves, each located with a center of mass at a distance d divided by 4 from the rotation axis, and ignoring self-gravity, a radial force of magnitude F equals 1 over 2 m omega 2 d over 4 will be exerted on each half. The associated tensile stress is function, where function, this is much smaller than typical tensile strengths of normal materials, and even of that of the comet 67P Churyumov-Gerasimenko. Thus, even when self-gravity is ignored, Oumuamua can easily withstand its centrifugal force. Tidal forces. The tidal force will be maximal if the long dimension of the object is parallel to the Sun object vector. Again, modeling the object as consisting of two halves, as in 4.1, the difference in the gravitational force experienced by the far and near ends of the object is function, where r is the distance of the center of the mass from the Sun. The associated tensile stress is a function. Even at perihelion, r equals 0.25 AU, the tensile stress is negligible. The critical distance below which tidal forces dominate over centrifugal is function. Thus, unless Oumuamua encountered an extremely close approach to a star in its past, it is unlikely that tidal forces played any significant role. Summary and discussion. We have shown that the observed non-gravitational acceleration of Oumuamua may be explained by solar radiation pressure. This requires a small mass-to-area ratio for Oumuamua of m divided by a equals 0.1 GCm to the negative second power for planar geometry and typical mass densities of 1 to 3 GCm to the negative second power. This gives an effective thickness of only 0.9 to 0.3 millimeters, respectively. For material with lower mass density, the inferred effective thicknesses is proportionately larger. Let's just read that for a second. I'm going to read it again. For a material with lower mass density, so they gave us a material with a certain mass density. Maybe this is important. I don't know. So they went through all their math and they come up with a certain mass density to where if Oumuamua was this certain mass density, they figured it into their math one way. But this here says, where did it go? This requires a small mass to area ratio for Oumuamua of m divided by a equals 0.1 GCM to the -2 for planar geometry and typical mass densities of 1 to the 3 GCM -2 power. This gives an effective thickness of only 0.9 to 0.03 millimeters, respectively, for a material with lower mass density. So if there was an alien material with a lower mass density, the inferred effective thickness is proportionately larger. So because I have a hard time myself looking at this object as a thin sheet, and the telescopes or the observers, I don't know. I don't know if that can get by. Can you get by something like that? I don't know. Can you slip a thin sheet by? Or in this case, for a material with a lower mass density, the inferred effective thickness is proportionally larger, or it could be larger. So you could have more of this cigar shape that I have in my head. This slate, stone, I don't know, idea that I have of this object in my head. We find that although very thin, such an object can travel over galactic distances, maintaining its momentum and withstanding collisional destruction by dust grains and gas, as well as centrifugal and tidal forces. For Oumuamua, the limiting factor is the slowdown by accumulated interstellar space medium mass, which limits its maximal travel distance to 10 kpc for a mean ISM particle density of 1 cm to the -3rd power. Our inferred thin geometry is consistent with studies of its tumbling motion. In particular, Belton et al. 2018 inferred that Oumuamua is likely to be an extremely oblate spheroid pancake, assuming that it is excited by external torques to its highest energy state. While our scenario may naturally explain the peculiar acceleration of Oumuamua, it opens up the question of what kind of object might have such a small mass to area ratio. The observations are not sufficiently sensitive to provide a resolved image of Oumuamua, and one can only speculate on its possible geometry and nature. Although periodic variations in the apparent magnitude are observed, there are still too many degrees of freedom, e.g., observing angle, non-uniform reflectivity, etc., to definitely constrain the geometry. The geometry should not necessarily be that of a planar sheet, but may acquire other shapes, e.g., involving a curved sheet, a hollow cone, or ellipsoidal, etc. Depending on the geometry, our estimated value for the mass to area ratio will change through CR in example 5. But the correction is typically of order unity. Known solar system objects like asteroids and comets have mass to area ratios orders of magnitude larger than our estimate of Oumuamua. If radiation pressure is the accelerating force, then Oumuamua represents a new class of thin interstellar material, either produced naturally through a yet unknown process in the ISM, or in protoplanetary disks, or of an artificial origin. Considering an artificial origin, one possibility is that Oumuamua is a light sail floating in interstellar space as a debris from an advanced technological equipment. Loeb, 2018. Light sails with similar dimensions have been designed and constructed by our own civilization, including the Icarus Project and the Starshot Initiative. The light sail technology might be abundantly used for transportation of cargo between planets. Gillocken and Loeb, 2015, or between stars, Lingham and Loeb, 2017. Our interviewee, Mr. Loeb, is involved in a bunch of this. I really want to get this guy on to interview. I want to do everything I can, guaranteed. In the former case, dynamical ejection from a planetary system could result in space debris of equipment that is not operational anymore, Loeb 2018, and is floating at the characteristic speed of stars relative to each other in the solar neighborhood. This would account for the various anomalies of Oumuamua, such as the unusual geometry inferred from its light curve, Meach et al. 2017, Fraser et al. 2018, Drawhouse et al. 2018, Bilton et al. 2018, its low thermal emission, suggesting high reflectivity, Trilling et al. 2018, and its deviation from a Keplerian orbit, McKelly et al. 2018, without any sign of a cometary trail, Meach et al. 2017, Knight et al. 2017, Jewett et al. 2017, Yee et al. 2017, Fitzsimmons et al. 2017. I'm just getting a whole bunch more people to try to interview, or spin-up torques, Rafikov 2018. So, I mean, there's the whole slew of what we're talking about here. This would account for the various anomalies of Oumuamua, such as unusual geometry inferred from its light curve, low thermal emission suggesting high reflectivity, deviation from Keplerian orbit, and without any sign of a cometary tail or spin-up of torques. Although Oumuamua has a red surface color similar to organic-rich surfaces of solar system comets and D-type asteroids and rust, this does not contradict the artificial scenario, since irrespective of the object's position as it travels through the inner space medium, its surface will be covered by a layer of interstellar dust, which itself composed of organic-rich materials. Drain 2003. Alternatively, a more exotic scenario is that Oumuamua may be a fully functioning probe sent intentionally to Earth vicinity by an alien civilization. Have we read it? Have we read? Is it just? I'm going to assume it's me. I'm going to assume it's me. I'm going to assume it's me. And I just haven't read enough papers in my history. Alternatively, a more exotic scenario is that Oumuamua may be a fully operational probe sent intentionally to Earth vicinity by an alien civilization based on the Pan-STARRS 1 survey characteristics and assuming natural origins following random trajectories. Doe et al. 2018 derived that the interstellar number density of Oumuamua-like objects should be extremely high. Function equivalent to function ejected planetesimals are going on a break. Ejected planetesimals on a break. See you on the other half. Other side.
Radio at freedomslips.com, and we'll be right back after this message.
Wadiya will remain a dictatorship. Or be quiet. Why are you guys so anti-dictators? Imagine if America was a dictatorship. You could let 1% of the people have all the nation's wealth. You could help your rich friends get richer by cutting their taxes. and bailing them out when they gamble and lose. You could ignore the needs of the poor for healthcare and education. Your media would appear free, but would secretly be controlled by one person and his family. You could wiretap phones. You could torture foreign prisoners. You could have rigged elections. You could lie about why you go to war. You could fill your prisons with one particular racial group, and no one would complain. You could use the media to scare the people into supporting policies that are against their interests.
Tune in Monday through Friday, 4 p.m. Eastern Time, for Liberation Nation with Deacon John, where America comes to hear the truth.
I know this is hard for you Americans to imagine, but please try.
Ohio Exopolitics will be on from 4 to 6 p.m. Eastern on Studio A. Mark Schneider will have guests on that will discuss many important topics, including the state of the world today. However, much of the show will be dedicated to the writings of Edward Albert Meyer. Let me read a short passage from one of his writings. Love is the highest principle of creation, and through it, everything exists in absolute logic. All of nature in its indescribable splendor is nothing but the love of creation, which is expressed visibly. The love of creation is everywhere, because without it, nothing at all would be able to exist. Please join Mark on Ohio Exopolitics from 4 to 6 p.m. Eastern on Studio A.
It is no secret that the so-called mainstream media is best described as controlled propaganda. Countless news stories are either totally ignored or spun with half-truths, and because of this, essential facts and vital information are often compromised. Join Dr. Ott every Friday night on Studio B at 10 p.m. Eastern and learn why The Story Behind the Story was nominated for a Peabody Award in its second year of producing unparalleled broadcasting excellence in 1997. That is, if you really care about learning the truth.
Transcending time and space, let us take you to the place inside your mind where thoughts divide and mysteries unwind. Join us every Monday evening right here on Revolution Radio at freedomslips.com from 8 to 10 p.m. Eastern Time. And you will catch the Fenton Perspective with our great host, Lorian Fenton. Come listen in as she shares her amazing stories from the past to present, along with all of her guest secrets to the future. That's the Fenton Perspective every Monday evening right here from 8 to 10 p.m. Eastern Time, only on Revolution Radio. Oh, and you don't need to expect us. We're already here.
The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Hey everybody, it's Francis. Our last segment on Collision Course, November 10, 2018. I'm going to call Chuck. Chuck's over on the chat room for Studio B on revolution.radio at freedomslips.com, and we're going to go ahead and see if we can make this work. Bear with me. If you're just joining us, we've been talking about Oumuamua and the latest paper. Chuck? Are you there?
Hello, this is Chuck.
Hi, Chuck. This is Francis. Are you there?
I am. How are
Chuck,
you,
can
man?
you hear me?
Yes, sir.
I'm doing fine. You can hear me. I can hear you. I can hear you fine. Good evening.
Oh, good. Good evening, man. This great show. I love this stuff.
I love this stuff, too. You know I love this stuff. I can't get enough of it, and I'm glad to be back doing it. And you know what? I found this season's a little different. I really don't need anybody else to enjoy this stuff. You know what I mean? I can just, I'll kill 2 hours quick.
Yeah. I've listened to all the formulas and stuff is like Boolean algebra, but just having someone like Harvard to come out and say this is something strange going on here is enough for me. I was wanting to. Did I miss anything about the metallic properties and stuff that they also said that they use
Okay. Well, what I've heard, what I've been told, because I talked to Karen Meach, who she was part of the discovery and all that process, and now since then we have all these new discoveries and these new papers that came out, is that what they basically came out and said, and I always find it almost an omission, is when they say, well, they can't rule it out, you know. When it was first introduced to us, it was introduced to us very innocuously. It was like just this. It was an interstellar traveler, but there was nothing very fancy about it. And then all the fancy really started to happen really fast after that. And from when I was talking with Karen and I brought up what it was probably made of, she talked about a rocky material, but then at the very last part of the sentence was, but we can't rule out that it was made of metal or a metal type asteroid. You know, when they come in iron asteroids and stuff like that. So it's just been shifting around from one thing to the next. But this whole paper I just read is riddled with astonishing words and phrases. You know what I mean? I talked about earlier about sketch science and how some sketch science that goes on right now in our environment, they don't have papers to back them up, and that's what makes them sketch. But then you have this paper which has all this sketch kind of information, and it's going to go off and be peer reviewed, and they're going to come back and say, oh yeah, that's all possible. Now, what's so fancy about that? It's almost, to me, and I don't know about you, is when I first started seeing these beautiful images of Mars, right? And you see this wonderful ice cap on the North Pole of Mars. You see this humongous ice cap, right? And I think to myself, when did we discover that Mars had water on it? And I'm thinking to myself, probably it hasn't been that long, has it? But yet there's this humongous ice cap on top of Mars. What took us exactly so long to discover that there was liquid water on Mars, except from our scientific community?
Holding us back or something. I don't know. I know Phobos is starting to come back into the news again, and there's a monolith on Phobos. Buzz Aldrin was wanting people to pay attention to it, and then for some reason he got real quiet about it again. And now I'm seeing it slowly.
You know, what's unfortunate for us as observers and even astronomers. Now, as a recent, that's where I talked a little bit about Mars quickly. We have my astronomer friends like Damien Peach. These are the folks that are taking these just incredible planetary images, and then you have the space missions that go out there and they take fantastic images of planets. But it's actually very hard for an astronomer on Earth to go and say, let's go see what's going on Phobos. You know, you literally have to have a satellite, or you're relying on somebody else's photo. And I always hate that. I dislike having to rely on other people's pictures to tell me what's going on someplace. But you really find this Oumuamua pretty interesting, don't you?
Oh, I do. I've always believed that there's something going on out there because I've had my own experiences, and I had no problem telling people I believe there's something out there, or it could be from here. Who knows?
Well, I'm finally
a lot of criticism from other people. Didn't you remember? I don't know if you ever met my ex-wife, but her name was Faye, and one day, she used to just roll her eyes at me when I'd show her something. Yeah. Well, one day we were at a little downtown area. We were doing like a NASCAR thing at the small town of Archdale. Something just told me to look up, and I looked up, and there was one staring me right now, a little white cigar-shaped object, and it wasn't moving. And I told her to look at it, and suddenly it started moving real fast and erratic in different directions, and her jaw dropped. So every time I brought something up like that again, she'd look at it and take it a little more serious. It means something else.
Yeah, and there are just report after report after report. I mean, everybody can't be wrong, right? Even if almost everybody is wrong, not everybody can be wrong. So I'm actually moving. Well, I don't know if I'm moving. I never, in my first season, and for most of the time, we weren't really on the topic of UFOs and alien life and what have you. And so I really didn't have to make my viewpoint one way or the other. But are you there?
Yeah, you were.
Okay.
You know what we all liked about you. You stayed on the facts and didn't just leak through the dramatics.
And I don't want to, but in this, for what I'm seeing and the advancement, good or bad, my feelings really are that there is a significant presence of an alien type. Not force. I don't know how you say it. It's just an alien intention. An alien intention. Let's call it an alien intention, because we don't know if there is an alien, for sure, because we haven't been introduced to one. But you can definitely have a sense that there is some sort of alien intention, whether we're creating it ourselves or not. But as we have these types of things like Oumuamua, it doesn't do anything but add to me feeling more like it's true.
Right.
Makes me feel like it's true. And like when they use these kind of words, I mean, it's just peppered with, alien this and alien that and artificial this and extraterrestrial that. When you start getting into a research paper that just can't shut up about extraterrestrial, there's nothing you can do but say, hey, they're talking about extraterrestrial stuff.
Yeah, and then the coincidences they throw in there that will bounce around in your head, like the name. How do you pronounce it? Oumuamua or?
I got it right. It's Oumuamua. It's Hawaiian, so you can just kind of think Oumuamua. So that's how.
And they named it that because they discovered that in Hawaiian, and then that name in Hawaiian happened to mean messenger or scout. So
no.
Come on.
And this was, and I'm going to go find it for you, Chuck, because this is what blew my mind. Okay, and this is why people can say, Francis, I don't know why you're hooked on it. I don't know why you're hooked on it, but I'm searching right now, Chuck, and I'm searching for Oumuamua translation. Okay, and I'm going to tell you, I'm going to go to a certain spot. And then I'm going to explain my whole thought pattern here. So I've searched Oumuamua translation into Google. I clicked on it. Now,
I read that on CBS News Report. They probably liked it.
Well, that's right. So I'm going to tell you, 99.9% of the translation of the name Oumuamua has come from the recent information that we're receiving. Okay, so just think of it. We first discovered it in October of 2017. So all the translations for what the name is come from the news and reports starting in 2017. I went and looked myself because I wanted to be sure. I said, listen, that's a weird name. They initially named it Rama, and Rama has something to do in Sanskrit, but not really traumatic, not like what Oumuamua meant. And I went and I looked, and they said,
well, immediately there's your point. They just sort of come up with that when they noticed the weird properties on it.
Well, there is a website, and it's called the Ulukau. It's ULUKAU. It is the Hawaiian Electronic Library. It was created as a dictionary of the Hawaiian language revised by a Mr. Henry H. Parker. Mr. Henry H. Parker spent most of the beginning of the 20th century as working for the royal family as a high, how do I want to say it? Like an elite, it was like their go-to scientist, okay? And Mr. Henry H. Parker, besides working for the Hawaiian royal family, he produced a dictionary of the Hawaiian language. And if you go into that dictionary, which you can find online at ulukau.org, and search Oumuamua, and here it is, Oumuamua, comma, and then just what the meaning is, Oumuamua, and then they break it down to mua, comma, the front. And then number 1, the meaning, the foremost soldier or the front rank in battle. Number 2, a scout, one sent forward before a battle to discover the position of the enemy. That's exactly what it says, Chuck.
Lord, I don't need it. Now, I guess they're just trying to get us paranoid if we do see something in the sky, run away from it.
It's so weird because these are scientific people, okay? So when the scientific people want to put a name on it, they somehow, I would think, would protect themselves and know the top and the bottom of what it means, right? So that you're not insulting someone from another culture, or you're not, you don't want your word that you're going to put on your face to mean poo-poo in some other language, right? So they knew exactly what it meant. There's no way except they're not reporting it exactly as it says. They say it's a scout or something, a time traveler from the distant past, flying by to say hello. The Miss Karen Meach, who I interviewed a few weeks ago, she did a TED Talk. And so when she translated what it meant, she said, a distant traveler from the past coming through to say hello. That's exactly how she said it. So that couldn't be any more different. That couldn't be any more different than a scout, one sent forward before a battle to discover the position of the enemy. Right? And people ask me, or they're not asking me yet. They may ask me in the future, what am I so paying attention to? It's right. It's in black and white. So I am not. I can't say that there is no warning to give here. There is, if anything, I could take a telescope and look in the direction of where it came from. If I thought other things were coming in from that direction,
like a fleet.
No, right. I mean, if you had a telescope and you wanted to see the fleet coming, then at least you know where they might be coming from. But it's almost funny. It's like Laurel and Hardy funny. You know Laurel and Hardy, right? Laurel and Hardy, they were funny, but they were sometimes emotionally funny, which meant, one would hurt the other one's feeling, and then that somehow would be funny. That's the kind of feeling I get when I think about this object, is that someone's trying to pull a funny on me and trying to touch me emotionally in a negative way.
Yeah. Well, they're planting a seed in a lot of people's head with it, because they know there's a lot of people out there wanting to know about it. They have different opinions on it, so Well, I think it wouldn't shock me if it was a scout or something like that, because a lot of people have been predicting this thing. It might be a different invasion than Trump's worried about.
Yeah, well, we're going to get an invasion one way or the other. Is that what we're talking about?
I don't think a wall's going to help this one, but.
Well, I can't help to think. I believe we were talking about, both of us maybe were thinking about writing a book in the future.
Yeah.
And
I started trying to write. I don't want to get into my book yet.
Yeah, well, no, and that's why I just want to not really segue into it, is that I've had this thought, this idea for this book in my head since 5 or 6 years now. And the hardest part about writing a book is the actual writing of the book, of course, right? You can have segments of the story, but you have to write it. So I'm finding it very interesting that the story of my book somehow could fit into the real life that I'm leading right now, which is I'm going to do it. We're just going to see what happens. And so behind what's actually happening in real life with an object we're not quite sure about, there could be, of course, a very interesting story to be told that could follow along with what's going on in real life.
That's true. I know what I was really, I need a little more time to research this stuff. I had a question. Is there a real picture of it? Or, the pictures they show, it looks like a blunt or something, but looks like an artist rendition.
Okay.
Seemed like a real picture of it.
Right. This is the, I'll tell you, I'll just explain to you. I was going through today myself. The only real pictures of it are pictures like I would produce my old pictures of the comets and etc. So basically like what you had is it would be a dot. There's nothing to you have to be a scientist hitting it with a spectroscope, and the scientists know exactly what kind of information they're getting back. For us and for telescope looks, it wasn't extremely informative. They tracked its, as it moves, it's rotating, so it got more bright and less bright. So they were tracking how it was rotating, and they were able to do all that. But I haven't been able to find myself a very good representation of it.
Yeah, I guess they didn't really have much interest in it until it started leaving. That's when it started acting abnormal and changing direction and gaining speed. And they're like, "Whoa, what's it doing?" Kind of too late to get an up close picture. If they wanted to, when it was coming in, they probably could.
Yeah, I really feel like once they recognized where it came from, which was like pretty quick, because the telescope takes the pictures, and then a human comes by and finds what's moving in the pictures after they've been taken. So I'm sure that once the humans who were doing the observing through the images discovered that it came, that it was really fast, and then it had a terrifically odd orbit, there was a instant rush to recognize it, because whoever recognized it first would somehow get their name attached to it, right? So there was an initial push for information and interest, and then it quieted down for a second until they really started tracking it and started finding out all these weird things. Because I'm reading in the papers that I read today, and this other thing that, and they use these kind of words, out of all the other comets and asteroids, this is the object that is of hundreds of magnitude different than any other object they've ever seen. So when they're using that kind of language, we have to take it for face value that this is an object that is unlike any other object they've ever seen before. Now, that's not telling us what it is or what it looks like. They're trying to tell us what it is. They're trying to tell us what it is, but they're not coming out with it. They're just it was
but it was very weird shapes of something coming through the space like that, they normally don't get a shape like oblong like that. Over years, they're more rounded, you know. But
yeah, well, that's the whole thing is like they use the words unlike any other asteroid or comet that they've encountered. So the more words they put in black and white, the more that it tells certain people that this thing is strange enough to keep looking. Now there is, I only got a minute or two. There is an article. Where is it here? And can I find it? They are. Okay, here it is, and I only got a couple minutes, so Chuck, hold on with me. I want to get this out. In 2025, SpaceX BFR and gravity slingshots for speed to reach alien Oumuamua object, the next big future.com 2025. In an article, they're trying to talk about, and this is why, now this thing's moving fast, right? But there are people right now trying to work on missions to get one of our spacecrafts out to go see what this thing really is. Speed, acceleration, and other reasons to think it's an alien solar sail. Again, they're talking about why they think Oumuamua is something strange. But I'll quickly just touch on the top things. They are planning for a couple of different versions where with certain spacecraft, they're going to use what they call a flyby. Instead of a flyby the sun to get the sun's gravitational pull, it's going to be very close to the sun's surface, and they call it a flyby, to get the speed to spit a spacecraft out to try to catch up to Oumuamua. And there's two choices. They might catch up to it in like 2031 at 80 AU, and then there's a mission to probably go all the way out to 155 AU before they'll catch up to it. Chuck, it was great talking to you. That's the last word.
Okay, buddy. You take care, man.
You have a great night, man. I'll talk to you again soon.
Okay.
Good night, everyone.